Good morning, students. Today we'll be looking at some of the questions from the same exercise, that is 13.1, and we'll be solving some questions from exercise 13.1. So here we go. Exercise 13.1, and we'll be looking at question number 18 onwards. Question number 18 we'll be doing second part. So what does question number 18 second part says? It goes something like this. Limit x tends to a, x to the power m minus a to the power m upon x to the power n minus a to the power n. You know the formula. I can write the formula in the bracket if you guys don't remember. The formula goes something like this: x to the power n minus a to the power n upon x minus a. The formula is n a n minus 1. This is the formula. So I'll be using the same formula, but I need the denominator, simple denominator, but it's not like that. So what I'm going to do, limit x tends to a, and then I'm going to write x to the power m minus a to the power m upon, I'll divide x minus a and multiply by x minus a. Okay, so I multiplied and divided by x minus a. और जो ये वाला पार्ट है, आई एम राइटिंग इट ओवर हेयर, x to the power n minus a to the power n, right, into करके. Okay, now I'm gonna give, see, limit x tends to a, this is going to become m a m minus 1. Do you guys all agree? And this, if I reciprocal it, what will happen? This is going to become, if I reciprocal this is going to become another formula, that is going to be 1 upon n a n minus 1. So this is how it's going to come. If you see this and put a formula in this, it's going to come 1 upon n a n minus 1. So if I reciprocal this and I bring it in the formula, then I'll get this formula. You guys can do it in the long method also if you want. Now limit x tends to a, now I can remove a limit because now I have made a formula out of it, so I don't have to put limit anymore. So m a m minus 1 n a n minus 1, this both are the same basis, so the powers are gonna go and get subtracted. M minus 1 minus n plus 1, so this goes on the top and gets subtracted. So that is how it's going to happen. Equals to m, 1 and 1 can get cancelled, m a m minus n upon n. So this is my answer. Okay, so that's how you solve the question. That is based on exponential, and the formula is already been given to you guys. Okay, let's look at one more question, that is question number 19. Question number 19th, we'll be looking at question 19th, and we'll be seeing second part, that is limit x tends to 0 square root 1 plus x minus 1 cube 1 plus x minus 1. We'll be looking at this question now. So what I'll be doing in this question, I'll say let 1 plus x equals to h, and h tends to 0. Okay, or h tends to 1 also, because if x is 0 then h tends to 1. Sorry, okay, why h tends to 1? Why? Because x to 0 है, तो बचा क्या h and 1, so h tends to 1. So limit x to, okay, and then I'll be putting h minus 1 upon h cube root of h minus 1. Now I'm going to put them in power, h 1 upon 2 minus 1, h 1 upon 3 minus 1. You know that we can write it like this: h tends to 1. This also h tends to 1, it's gonna come. Now you know when there is this formula which is powers, I can write powers with this also, power with this also, right? Same powers. 1 to 1 ही रहेगा. I can give 1 any power, it's gonna stay 1. Even if I give 1 power 0, it's gonna stay 1 itself. Okay, now if you guys see, I'm gonna do what? H 1 upon 2 minus 1 upon 2, and I'll multiply and divide by h minus 1 or also multiply by h minus, divide by h minus 1, multiply by, and h 1 upon 3 minus 1 1 upon 3, I can write it like this. Now limit, whenever we put limit, we can bring a formula out of it. What is the formula? N a n minus 1. So what is n over here? Half. What is a over here? A is 1. Okay, and that's gonna stay like this. Now into this, the formula for this is going to come is 1 over, नीचे आएगा formula 1 upon 3 into 1. Okay, now you guys can see what we can do. 3 will go up and 3 is gonna go up, so it's gonna be 3 upon 2. जब आंसर निकालोगे आप तो आपका आंसर क्या आएगा? 3 upon 2 as an answer. Okay, so I made a formula out of it. फॉर्मूला कौन सा लगाया मैंने? एन ए एन माइनस 1 वाला, और इसमें भी सेम फॉर्मूला लगाया, एंड दिस इज गोइंग टू कम, बिकॉज ये फॉर्मूला रेसिप्रोकल्ड है, जो आंसर आएगा वो भी रेसिप्रोकल्ड में आएगा. सो दिस इज माई आंसर. दिस इज व्हाट माई आंसर इज गोइंग टू बी 3/2. Okay, I hope you guys are getting this. Okay, let's have a look in question number 22, second part. There are so many questions as question number 22, second part, and so I'll be doing one of the question like this. So question number 22, second part says, if fx, the function, equals to curly bracket x plus 1. x plus 1 हमें कब इस्तेमाल करना है? When x is greater than 0. Okay, like 1, like 0.1. And this, when do I have to use it? When x is smaller than 0, like -1, minus 0.1, something like that. So what I'm going to do, I'm going to find the limit x tends to 0 from the negative side. Okay, and then, so which function will I put? Think about it. Which function will I put? I'll be putting the function x is less than 0, so I'll be putting this function. So which is going to give me, please have a look, x tends to 0, so 0 minus 1, what will I be getting? -1. What is the limit I got? I got -1. Okay, now I'll find the limit x tends to, जो पॉजिटिव साइड से, दो साइड से आते हैं ना, नेगेटिव और पॉजिटिव. ओके, नाउ जब पॉजिटिव साइड से आ रहे हैं तो कौन सी लूंगा मैं? x इज ग्रेटर देन 0. आई विल टेक दिस वन, दिस इक्वेशन, बिकॉज जब पॉजिटिव साइड से आऊंगा तो मैं कौन कौन से नंबर लूंगा? ऑल द पॉजिटिव नंबर. सो आई विल टेक दिस इक्वेशन. सो विच इज गोना बी, so can you guys see one thing, that at limit x tends to 0 minus is not equals to limit x tends to 0 positive जो fx है. It's not equal. So when they are not equal, what do I write? I write that limit for limit for x tends to 0 of fx does not exist. When जब हम नेगेटिव साइड से आ रहे हैं, लेफ्ट हैंड साइड से आ रहे हैं और राइट हैंड साइड से आ रहे हैं, जब आंसर सेम नहीं होता तो वी से लिमिट डज नॉट एग्जिस्ट. ओके, सो दैट्स हाउ इट हैपेंस. Okay. Okay, let's start solving question number 1 of 24th part, first part. But let's read question number 24th first. This is question number 24. What does question number 24 says? Let f be defined by, so f can be defined, the function can be defined by 3x minus 1. When will this function work? When x is less than 0, like -1, -2, और जो आपने नंबर लाइन देखी है, जब भी 0 से कुछ भी नंबर आएगा, -0.01, then also I'll use this. When x equals to 0, then I'll use this equation. When x is greater than 0, then I'll use this equation. Okay, so what do I have to evaluate? I have to evaluate fx limit from x tends to 2, and I have to find the function. Okay, I have to find the function का limit ढूंढना है मुझे, limit कहाँ तक है. ठीक है, so what will I do? You guys can see x tends to 2. If x tends to 2, it is positive 2. What do you think, which equation will I use? This one, right? Why? Because x tends to 2, which x is greater than 0 and 2 is greater than 0. So I'll use this one equation. So 2x plus 5, and then I can put the value 2 into 2 plus 5, and then I'll get answer as 9. And then for the second part, what will I do? I have to find the limit x tends to minus 3, which equation will I be using? This one, because x is smaller than 0, or smaller than 0 is minus 3, so I'll use this equation. Okay, so limit x tends to minus 3 fx, that is going to 3 into minus 3 minus 1, so that is going to be minus 10. Now but there's one more question. If you read the line, does, it says does limit for x tends to 0 of fx exist, they're asking. If no, explain why. Okay, this is the question. So what I'll find for 0, जब ऐसे numbers होते हैं simple numbers, we know, we are very clarified that कि x is greater than or x is smaller than 0. Whatever the smaller numbers, I'll use this equation. Whatever the bigger numbers, I'll use this. But whenever it's 0, in all the equations it's coming 0. So I'll figure that out कि let's figure that out कि limit x tends to negative side से. So what will I be using? I'll be using this negative side से. I'll be using this 3x minus 1. So when I put the value of 0, 3 into 0 minus 1, and my answer is minus 1. And for limit for x tends to 0 positive side say, then I'll use this equation, that is going to be 2 into 0 plus 5, so that's going to bring me answer as 5. So tell me one thing, is limit x tends to, okay, from the negative side 0, is that equals to limit positive side से fx का? I don't think so. It's not equal. So I'll say the limit does not exist for this, for x tends to 0. Okay, I hope I'm making myself clear. So when it's 0, you have to find from negative and positive side, because in all the equation 0 is coming. So if it's coming from negative side, I'll be using this equation, and if it's from positive side, I'll be using this equation. But I'll be putting 0 in the equation, and I'll see if the answers are coming same. If the answers are not coming same, I'll say limit does not exist for them. Okay, let's have a look in question number 25 now. Okay, let's have a look in question number 25. Find k so that limit x tends to 2 fx may exist. It exists where x, now 2 दोनों में है. So what I'll do, I'll find that limit x tends to 2 नेगेटिव साइड से. जब मैं नेगेटिव साइड से जाऊंगा, सो व्हाट आई एम गोना यूज, जो फंक्शन में विच इक्वेशन विल आई यूज, दिस वन, because x is smaller than or equals to 2. So I'll use this equation, that is 4 into 2 minus 5. And what is my answer going to be? Think about it. 4 to the 8, 3, right? And if I'm going limit x tends to 2 positive side say, I'll be using this equation, right? So if I use this equation, what will I be getting? I'll be getting x, that is 2 fx, ठीक है, equals to 2 minus k. But they have already said find k so that इसकी लिमिट है, देयर एग्जिस्ट. सो अगर लिमिट है तो मैं क्या लिखूंगा कि आई एम राइटिंग इट ओवर हियर, लिमिट x टेंड्स टू 0 नेगेटिव साइड से ऑफ fx इज ऑलवेज इक्वल्स टू लिमिट x टेंड्स टू 0 पॉजिटिव साइड से ऑफ fx. So what is the answer for this? 3. What is the answer for this one from positive side? I have 2 minus k. So when I shift k on this side and 2 minus 3 on that side, so what is the value I'll get? Minus 1. So what's my answer? Minus 1. Are you guys getting it? So that's how you do all the questions from exercise 1, 13.1. It's not very hard exercise. You'll be able to do it. Okay. Thank you so much for watching this video. Have a good day, everyone.